Hello again, Year 6s. Last video of the week this week, and today you're looking at sequences. Now, last week, hopefully, you had a bit of a look at Fibonacci's sequence. Amazing. Today, your sequences are a little bit more straightforward, not quite so complicated. They're fairly straightforward linear sequences, and you're going to be thinking about the pattern, and hopefully, you're going to get on to thinking about the nth term. Again, something we've talked about this year, but it's a really important thing to start understanding as we get into sort of more algebra and mapping out sequences and predicting different terms in a sequence. So I want you to listen really carefully as we look through these learning reminders. I'm just looking at the learning reminders. You can do this on your own if you want to. If you're bored by my voice, that's perfectly fine. Go have a look yourself. But hopefully this will be a bit helpful just to lay things out easily. So you can see two sequences here, and I reckon you're very clever. You can see what's going on. 1, 8, 15, 22, 29. Can you see what's going on? Can you tell me what's happening each time? Hopefully. Okay. Can you tell me what the next three terms would be? Can you do it? What would they be? How about this one? 95, 89, 83, 77. Hello, Ziggy's come to say hello. Maths Dog has come to join us for a moment. Let's have a say hello, Ziggy. Say hello. No, he's gone. That's fine. That was my also all of our messy washing over there. But Maths Dog is not around today, but he just popped in for a quick hello. He's been out for a walk. So what's this sequence? What's happening? This one's counting down. This one's counting up. Have you worked out what the next three terms would be? Can you tell me what the pattern is? Let's have a look. All right, there you go. All right. So these ones were increasing in sevens, okay, just nice and steadily, weren't they? Going up in sevens. This one decreasing by 6, okay, each time. All right, and so you could carry on these patterns. Okay, this one would get to 0 in the end, and we'd have to keep going the other side of 0. In fact, it would never reach 0. I can tell you that for free. But we'd have to go back. We'd end up in negative numbers if we needed to. But that's fairly straightforward, and you are quite good at that, I think, team. You can do a bit of that. But the question is, can we use our knowledge of sequences to predict what the nth term will be, what any term in the sequence would be? So here's another sequence. It goes 2, 5, 8, 11. Okay, it's going up in threes each time. The difference is 3. The next would be 14, and then 17, and then 20, and then 23, and 26, and 29. So here we go. This is where our vocabulary starts to come in, okay? N is the number of the term in the sequence. The first term is 2, okay? The second term is 5. The third term, and on and on and on. The 10th term is 29. Okay, so when n is 7, t is 20. When n is 3, saying this down here, t is 8. Okay, now could you predict what the answer will be, what the number will be when n is 20? What could we do? I'm just going to double this. Is that going to work? I'm not sure it is, because that's not quite how sequences go. What we have to do is look at what the relationship between these numbers is. All right, so let's have a look further down here. Okay, it goes up in threes. It's like the 3 times table, but the t's, the terms, each term is actually 1 less than a multiple of 3. Let's have a look at them. This is 1 less than 3. This is 1 less than 6. This is 1 less than 9, which is 3 times 3. This is 1 less, do you see? This is 1 less than 30. So, what's the 20th term going to be? It's going to be 1 less than 20 threes. 20 times 3. Okay, so it's going to be what? Hopefully, we'll see the answer down here. The 20th term is going to be 59. And we can write this as a formula. This is where it gets exciting, okay? We're timesing n by 3, and then we're taking away 1. That's what we're doing every time. 1 times 3, take away 1, 2. 2 times 3, take away 1, 6. 3 times 3, 9, take away 1, and on and on and on and on. So we can write this by saying 3n minus 1. That is the rule for this sequence. Whatever n might be, if n is 500. All right, we're going to say it's 3n, 3 times 500, 1,500. Take away 1 is 1,499. That would be the 500th term in this sequence. All right, that's quite hard, girls and boys, and you're probably going to need to come back and read through these again because I've scrolled through them quite quickly, wiggled about a bit. Have a careful look. All right, just quickly with another one: 5, 9, 13, 17. What's it going up in? 4s. All right, so it's a bit like the 4 times table, but what do we notice? This is 1 more than 4. This is 1 more than 8. This is 1 more than 2. Hello, we found it again. Okay, so 4n plus 1 is t. All right, 4 times 1 plus 1 is 5. 4 times 2 plus 1 is 9. 4 times 3 plus 1 is 13. 4 times 4 is 16 plus 1, 17. So we could, they found the 11th term. 4 times 11, 44 plus 1 is 45. And then they just checked it by carrying on. All right, that's what you're going to be doing today. You're going to be looking at lots of different sequences. Now, I've put a mild on the hot again. I'd like you to have a go. See if you can see patterns. See if you can work out, right, this is the n, okay? This is the number in the sequence, and this is the term. What's going to happen? Have a go. Do some good maths. Patterns is tricky, but I'm looking forward to hearing how you get on with it. Good luck. Have fun. Good maths.